Hey guys, okay, so today I want to talk about exponential functions and talk about growth and decay. So with an exponential function, it will look like y equals b raised to the x value, okay? So some rules, b has to be greater than 0, okay? Because 0 to the first is 0, 0 to the second is 0, 0 to the third is 0. So b has to be greater than 0. b also cannot be equal to 1 because 1 to the second is 1, 1 to the third is 1, 1 to the fourth is 1. Okay? So when we talk about exponential growth, it's when b is greater than 1. And our exponential growth graph will look just like this. So it starts off slow, and then all of a sudden it jumps up. So this is similar to like chemistry class when you guys grow bacteria. So you put the bacteria in a petri dish, and you wait and you wait and you wait, and nothing happens. And then I think on day 3, all of a sudden you come in and it's overgrown with bacteria. That is exponential growth. It happens very, very quickly and very, very fast. So exponential growth is when b is greater than 0. So b is whatever you are being raised to the exponent. Decay is when b is between 0 and 1. So that's a fraction or a decimal. So this is growth. So our decay graph is going to look like this. Okay? So this is, it happens very quickly, and then it slows down. So that's decay. What I do want to tell you is these will go on forever, and this is called an asymptote. So an asymptote is a line that a graph approaches, but it doesn't cross it. So it will get really, really close to 0, but it will keep going. This way, same thing. So we call this an asymptote with little lines. So let's just discuss what is growth and decay. Here is an equation you might see. The only thing I care about is the number that's being raised to the exponent. 0.5. Is it greater than 1, or is it between 0 and 1? Okay? That is less than 1, so it's decay. 2, is it greater than 1? That is growth. 0.4, that's decay. 6, greater than 1, that is growth. So the only number, these numbers out here, does not matter. You are looking at the number that you are raising it to the exponent. So how do we model this? Well, we have a formula that we use. Okay? This is your initial amount. So this is what we're going to use when we're given word problems. Okay? Sorry. This is your final amount. This is your initial amount, so where do you start? This is plus for growth, minus for decay. That is the rate that happens, and T stands for time periods, okay? So if we take a word problem, let's see. We will do, we'll do this one. So we are going to use our formula. And our word problem, let me put this next to it. Okay? Our word problem is the amount of freight transported by rail in the United States was about 580 billion. Okay? So I like to highlight key things from my word problem. 580 billion ton miles in 1960 and has been increasing at a rate of 2.32% per year since then. Write a function representing the amount of freight in billions of ton miles transported annually. So 1960 is year 0. So I'm going to come back over here. So we started, so A of t, I'm looking for my final amount. Our initial amount was 580. And it said we are increasing, so it's going to be 1 plus, we're increasing by 2.32% per year. Now, with percentages, I need to transfer into a decimal. So you're going to divide by 100, or just move your decimal to the left twice. So it's 0.0232. Okay? So it's 1 plus 0.0232 raised to the t. Okay, so that is our function representing this. Now, when they ask us to graph it, okay, we pretty much like to stay around our origin. So our x values, you can choose any x values you want. I chose a -2, a 0, a 2, and I got this, so I just wanted one more, so I added the 4 on there. And my y values came out really, really high. And of course, I want you guys to use a calculator for this. You do 1.0232 raised to the 4th first, then you multiply your answer to 580. So when I graphed it, this is what my graph looked like. And because they were so high, I just adjusted my scale so it didn't start 1, 2, 3, 4, 5. I actually just started it close to 550. Okay? And then once you graph it, they're going to ask you a question about your graph. So in what year would you predict that the number of ton miles would have exceeded or would exceed 1 trillion, which is the same as 1,000 billion. So I'm trying to think about, okay, well, this is my years. How many years will it take me to get 1,000? So you're just plugging in. These are years. So these are going to be your exponents. So I plugged in, the 4 was 635. When I plugged in an 8, I got 696. The 12 as an exponent, I got 763. It's taken a really long time to move. So I jumped year 24, I hit 1,005. So in year 24, I'd hit the 1,000 billion for that one. Okay? Identifying if it's an exponential function. Okay? So they said, okay, well, is this an exponential function? No, because the variable is not the exponent. Okay? So the variable has to be in the exponential position. This one. Okay, so my variable is the exponent, but it's 0. Remember, 0 to the first is 0. 0 to the second is 0. So no, this is a constant function. Okay? So what about f of x equals 1 times 0.5 raised to the x? How about I change that times to this? Yes, my variable is the exponent. So that is an exponential function. All right, that sums up 4.1. Thanks, guys.